Now the next thing I want to talk about is the horizontal shift and what exactly happens when you're talking about horizontal shift. Now in this case, your graph for a horizontal shift will be of the form f of x equals x minus h and then the whole quantity squared. And again, since this is a quadratic equation, we know your graph is going to be a parabola that has the same shape as the graph of the x squared function. Now, since we are talking about horizontal shift, we know that your graph is going to move by h units horizontally, and that happens again depending on h. If h is positive, your graph will move h units to the right. If h is negative, your graph will move absolute value of h units to the left. Again, why absolute value? Since h is negative, you want to use absolute value for your h so that we know in terms of positive number how many units to go to the left hand side. And of course, your vertex is going to change. This time, your h will be the x coordinate, so your x coordinate will change by whatever this value of h is. Now what you need to keep in mind is that your function here is x minus h. So when h is a positive number, this sign will continue to be negative. If h is a negative number, which is what your other condition can be, in that case, this sign will change to a positive number because since h will be negative, the two negatives will make a positive. So let's go ahead and take a look at an example to see how this horizontal change will affect our graph. Now let's say we have a function of this form. Okay, we're trying to graph f of x equals x squared, which is our base function, g of x, which is x minus 2 whole quantity squared, and our third function is h of x, x plus 4 squared. Again, we're going to try and find the vertex, the axis, the domain, and range for each one of these functions. So as I was telling you earlier, when you have a positive h, you're going to move to the right. So in this case, when you have x minus 2, that means that your h is 2 and it's a positive number. When your h is negative, you move h units to the left. In this case, you have x plus 4. So that tells you h itself is negative, and that's going to be a negative 4 because you end up with a positive sign here, and by default your sign should be a negative number. So when you see a positive, you know that h is going to be a negative number. So again, like we did earlier in our vertical shift, we'll go ahead and make a table for each one of our examples. Okay, and I've already done that here. So as you can see, when you have f of x equals x squared, you will go ahead and select some values for x. So I have used the same values as before: 0, positive 1, negative 1, positive 2, and negative 2 for my x. And if you plug that into your f of x function, x squared, 0 squared is 0, 1 squared is 1, negative 1 squared will also give you a positive 1, 2 squared is 4, and negative 2 squared is positive 4. We will do the same thing for our g and h functions. Okay, so for our g, I have used x values as 0, 1, 2, 3, and 4, and I take each one of these x values and substitute right here in my function definition. So 0 for my x will give me negative 2 squared gives you 4. If I substitute 1 for my x, 1 minus 2 gives me negative 1. Negative 1 squared, of course, positive 1. So in the same way, we went ahead and used these numbers for our g of x function. Do the same thing for your h of x function. Now what numbers you choose for your x, again, is completely optional. The reason I selected these certain values here was because I wanted to use something that would work with our y values. I wanted to keep all my y values the same, and that's why I used these particular x values, but what you want to do, what numbers you want to use is the same thing. Now again, for your h of x function, if you're using -6 as your x value, you will substitute that in the function definition. -6 plus 4 will give you -2. -2 squared gives you +4. Okay, so in the same way, go ahead and make your tables. Again, you can see I have 5 points for each one of my functions. And then on a coordinate plane, we'll go ahead and graph each one of these f, g, and x functions. And this is what your graphs will look like. Okay, so using these same tables here, I went ahead and graphed our functions. So you can see this one right here in the middle is your f of x function using these points, this table right over here. Okay, your g of x is this graph over here. G of x was x minus 2 quantity squared. I used these values to go ahead and graph my g of x function, and as you can see, since our h was a positive value, which is +2, from your starting point, which is f of x function, your graph has moved 2 units to the right. Okay, so when I had x minus 2 quantity squared, my graph moves 2 units to the right. For your h of x function, again, I use the same table here to go ahead and graph our h of x. And you can see that we had x plus 4 quantity squared, and as I was telling you, your h value by itself was -4, and that's why we have moved 4 units to the left. Okay, so when it's positive, you move to the right. When it's negative, you move to the left, and you can see how that horizontal shift takes place. Now, unlike your vertical shift, your horizontal shift, of course, you can see your vertex changes, but also your axis is going to change, because now each one of these functions is going to have a different axis. Again, remember, the axis passes through the vertex for each one of these graphs here. So let's go ahead and see what these values should be. Your vertex, your axis, and then your domain and range. So we'll start with the vertex for each one of these functions. Now again, remember, the vertex of a parabola is the lowest point for that parabola. So if you look at your f of x function, which is right here in the middle, your vertex is at the origin, and that's going to be the point 0, 0. Your g of x is the function that moved 2 units to the right. So of course you can see that your vertex now is at x equals 2 and y equals 0. So your vertex is moved by 2 units, and again, this x coordinate in your vertex is the same thing as what your h value for a horizontal shift is. Let's look at the vertex for h of x function. This was the function that moved 4 units to the left. So as you will see, your vertex also is 4 units to the left, and it's at -4, 0. Okay, so you can see how each one of these vertices are different with the horizontal shift. Now, as I was telling you, your axis also has changed. Now again, remember, axis is the vertical line that passes through the vertex of your parabola. And for our first f of x function, the axis is the same thing as your y-axis. The equation of y-axis, of course, is x equals 0. For g of x function, of course, since you move 2 units to the right, the axis also moves 2 units to the right, and that will be the vertical line that goes through the vertex. In this case, it will be the vertical line x equals 2. And for h of x, the axis moves 4 units to the left, and it's going to pass through x equals -4. Okay, so again, your axis for each one of these is the same value as what your h value is, okay? That leads us to the domain for these functions. Now, the domain of f of x is going to be -∞ to +∞, as you can see from the graph. even though your g of x function moved 2 units to the right, it is still going to cover all values on the x-axis. So for your g of x also, the domain is the same, negative infinity to positive infinity, and you will experience the same thing for the h of x function. You're going to cover all values on x-axis as these two arms will keep extending. Now we want to talk about the range. What happens to the range of these functions? Has your range changed or does it stay the same? Now let's look at our graphs again. Now you can see, unlike your vertical shift, your graphs here didn't move up and down, they just moved horizontally on the x-axis. So for all three of these graphs, you don't see any part of the graph below the x-axis. There's nothing there. All the graphs are starting at x-axis and they're going to positive infinity with respect to your y-axis. So for your range, you're starting at y equals 0 and you're going all the way up to positive infinity. So for all three of these graphs, the range stays the same and it's going to start at 0 and go all the way to positive infinity. Okay. Now the next thing that we want to look at is involving an example that has both horizontal and vertical shifts. So instead of looking at two separate examples, we want to try and combine these in the same example itself. So this one we're going to try and work on it together. Now here your function definition is x minus 2 squared plus 1. Now remember, this here, x minus 2, if you had that by itself, would have been a horizontal shift, and if you had x squared, if you didn't squared plus 1, would have been a vertical shift. So that's how we're combining both of them here together. Now just like we did with our earlier examples, we'll go ahead and make a t-chart. We'll go ahead and graph that function, and then we will answer the vertex, axis, domain, and range. So let's go ahead and start by making our table here. Now we are going to use the points, again, 0, -1, 2, -2, and we'll also go ahead and add in the number 3. Okay. Now, to find your y values, you'll substitute 0 in your function definitions for x. So 0 minus 2 is -1, -2 squared, which is 4. 4 plus 1 is 5. Okay. Now we'll move on to 1. When you put 1 in your, have this minus 2 in there, x function definition here, 1 minus 2 is -1. -1 squared is 1. 1 plus 1 gives you 2. Okay, so we'll do the same thing for all of these points here. -1 minus 2 is -3. -3 squared is 9. 9 plus 1 is 10. Okay, so basically all I'm doing is taking these numbers, substituting my x with those numbers, and solving this. So if you need to do it on a calculator, go ahead and figure out what these points are going to be. So when x equals 2, y equals 1. When x equals -2, y equals 17. And when x equals 3, y equals 2. Okay, so again, go ahead and verify these if you want to. Now we'll take these points and go ahead and graph it on our function, our coordinate plane here. Now what I am going to do here is I am going to go ahead and write these in increments of 5, 10, 15, just so that we can get the whole graph in there. And these will stay 1, 2, 3, 4, 5. These are just increments of 1. Questions. Okay, we'll start with 0 at 5, 1 at 2, so that's going to be somewhere right here. -1 is at 10. let's see, 2 is at 1, so it's going to be somewhere right here, not on the x-axis, it's going to be a little above the x-axis. Negative 2 is at 17, so it's going to be somewhere about here, I believe. Okay, and then 3 is at 2. Okay, so it looks like we have partial curve here. Let's go ahead and see what happens when you put x equals 4. If I plug in 4 for my x value, I should end up with 4 minus 2 is 2, 2 squared is 4, 4 plus 1 gives us 5. So that way, we have a good set of numbers here. So 4 is at 5. I think that gives us a pretty good idea. So we can go ahead and combine all of these points together. So of course that end will also grow, and this is our f of x function here. Now you can see what the graph looks like. It's of course a parabola shape, but your x square function, of course, we know is at the origin. That graph looks something like this on here. Okay, so of course you can see that this would, our x square graph is here. Compared to that, this graph has moved to the right. Obviously it's not at the center of the coordinate plane, and also it is shifted 1 unit up. You can see it's not starting on the x-axis, it starts right here a little bit above the x-axis. So that means your vertex has moved to x equals 2 and y equals 1. Again, remember, your vertex is always the h from the horizontal shift and the k from the vertical shift. So your horizontal shift was 2 units to the right, your vertical shift was 1 unit to the up, as you can see from the function definition, and so that's what your vertex is going to be. Your axis always passes through the vertex, the x coordinate, so that will be x equals 2. If you look at the domain of this function, again, it's going to cover all negative to positive infinity on the x-axis as it grows. So domain stays the same. And what about the range of the function? Again, remember, your graph is not starting at x-axis, it's 1 unit above the x-axis, so that tells us your range is starting at y equals 1 and it's going all the way to positive infinity. So including 1, you're going to positive infinity, and that's going to be the range for this function. So graphing methods, we're still using the same thing as we had done before. Just select some x values, find your y by substituting into the function definition, and then find those points and go ahead and plot it on a coordinate plane, and you will come up with what your graph should look like. So just to put it all together, now anytime you have horizontal and vertical shifts in the same graph, okay, your default function definition will be f of x equals x minus h quantity squared plus k, where the h represents the horizontal shift, the k represents the vertical shift. Okay, it's going to have the same shape as the graph of f of x equals x squared, but this time your vertex is going to be h, k, your horizontal, your vertical shift, and the axis will of course pass through the h or the x coordinate of your vertex, which will be x equals h, and that's what we had right here in this example. The 2, 1 represents your hk, and x equals 2 represents your x equals h.